Hi, I'm Ms. Hall, and this is Lesson 78, Sinusoidal Regression. Using technology to find trigonometric models. Another way to model sinusoids is to use a graphing calculator that has a sinusoidal regression feature. We've run many regressions before. We've done a linear, a quadratic, probably a power and an exponential. Now we're going to do a sinusoidal regression. The table shows the number n of hours of daylight in Denver, Colorado on the 15th day of each month, where t equals 1 represents January. Write a model that gives n as a function of t and interpret the period of its graph. So we run a regression the same way as we ran the others. You first enter this information under Stat, Edit. Okay, L1 is going to be all the x values. In this case, that's a t. For t is the month, the 15th of each month, and then L2 is the y values. In this case, it's the capital N, and is the hours of daylight. Once you have that, you go to Stat, Calculate, and now we're looking for a sinusoidal regression. So we're going to go down, go past linear regression, quadratic, cubic, quartic, another linear regression, natural log, power. Oh, it was at the end. So on my calculator, it is C is a sinusoidal regression. I press enter, and I press enter again. And this will give me the A, B, C, and D values. Now we'll have to look at in class. Some of you with newer calculators, you'll have to enter more information. But no matter what type of calculator you have, when you run the sinusoidal regression, these are the values you should get. So I've rewritten the information the calculator gave me in function form. I rounded everything to the nearest hundredth except for the last one, which I can do now. 1, 3. And so write a model that gives n as a function of t. Great, done, and interpret the period of its graph. So the period is 2 pi over the absolute value of b. b in this case is 0.51. When I divide that, I get about 12.32. And remember that t, because if I were to graph this, I would get some kind of graph where it goes up and then down and then back up. Okay, so the period I have is about 12, and the x value is months. This represents months. So a complete cycle is 12 months. And that makes sense because we would expect the number of hours of daylight to fall in a yearly cycle, which is 12 months. Example 1, finding trigonometric values. Given the sine of theta equals 4 over 5 and pi over 2 is less than theta is less than pi, find the values of the other 5 trigonometric functions of theta. It's going to help me if I draw a unit circle and label my quartile angles in radians. So I know that theta is between pi over 2 and pi. So theta is in quartile 2. I can sketch a picture of theta. It's got to end somewhere. The terminal side has to be in quadrant 2. And now I know that the sine of theta, so I'm going to draw my right triangle. Okay, and the sine of this angle is going to be 4 over 5, and sine is opposite over hypotenuse. So opposite 4 over 5. Knowing the Pythagorean theorem, I know that missing side is 3. And now since it's in the second quadrant, that value is a -3. And with that, I have everything I need to find all 6 trigonometric functions. Let me label the pieces of this triangle: hypotenuse, opposite, and adjacent. So we have sine of theta, cosine of theta, tangent of theta, and then we have cosecant of theta, secant of theta, cotangent of theta. Okay, sine, opposite over hypotenuse, 4/5. Cosine, adjacent over hypotenuse, -3/5. Tangent, opposite over adjacent, 4/3. 3 is negative. I'll bring it up top. And now the bottom functions are just reciprocals of the top. This is 5/4, 5/3, negative, 3/4, negative. Okay, and just this is the last example of the unit, so let me write something else you should have learned, and we can double check our work here, is that all students take calculus. So in quadrant 2, only sine and its reciprocal should be positive. And that is true. Those are the only functions that are positive in quadrant 2.